Picture this, a massive nuclear submarine, sleek and silent beneath the waves, suddenly blasts off from the ocean's surface like a rocket, piercing the atmosphere and hurtling into the stars. Would it survive the vacuum of space? Could it cruise among the planets, its crew gazing at distant galaxies instead of deep-sea abysses? Or would it crumple like a tin can in the cosmic void? This isn't just wild speculation, it's a thrilling dive into engineering, physics, and human ingenuity that bridges to extreme frontiers, the crushing depths of our oceans and the infinite expanse of space. Buckle up, because we're about to explore if a submarine could double as a spaceship, blending hard science with jaw-dropping possibilities that will leave you questioning everything you thought you knew about exploration. Welcome to our channel, where we unravel the universe's biggest what-ifs with mind-bending detail. Let's launch into this adventure. First off, let's tackle the core problem head-on. Why even ask if a submarine could work as a spaceship? At first glance, it sounds absurd, like strapping wings to a tank and expecting it to fly. But think about it, the ocean's depths and outer space are Earth's most unforgiving environments, both demanding vessels that shield fragile humans from deadly pressures, isolation, and life-threatening hazards. Submarines plunge into the abyss, where water crushes with forces up to 1,000 times atmospheric pressure at the Mariana Trench's bottom, over 11 kilometers down. Spaceships, meanwhile, face the opposite, a perfect vacuum where internal pressure pushes outward and there's no air to breathe, no gravity to ground you, and radiation bombarding from all sides. The engineering challenges are flipped mirrors of each other. For a sub to survive space, it'd need to handle zero external pressure without exploding, propel itself without water for thrust, and protect against cosmic rays that could fry electronics and crew alike. Propulsion is a nightmare submarine. Screws spin uselessly in vacuum, and nuclear reactors, while powerful, rely on seawater for cooling, which doesn't exist in space. Then there's weight. A Virginia-class sub tips the scales at 7,800 tons, far too heavy for current rockets to launch into orbit without absurd fuel costs. Radiation shielding. Subs use steel hulls for pressure, but in space, you'd need layers against solar flares and galactic cosmic rays, adding even more mass. Microgravity flips everything, fluids float, bones weaken, and systems designed for buoyancy fail. Yet, intriguingly, real-world data shows overlaps. NASA's Extreme Environment mission operations use underwater habitats to simulate space missions, training astronauts in neutral buoyancy tanks that mimic zero, while skeptics point out the insurmountable differences, like a sub's inability to withstand re-entry heat exceeding 1,600 degrees Celsius. Recent breakthroughs in materials science hint at possibilities. Imagine the urgency if we could repurpose subs for space. It could slash costs for deep space missions, turning naval tech into cosmic explorers. This problem isn't just technical, it's a testament to human curiosity, pushing us to blend worlds we thought incompatible. Now, let's zoom in on the current state of affairs, where submarines and spaceships already share more DNA than you might think. Both are essentially lifeboats in hostile realms, sealed capsules, sustaining air, water, food, and power for weeks or months. Take nuclear submarines like the Ohio class. They generate their own oxygen via electrolysis, scrub CO2 with amine absorbers, and recycle water, much like the International Space Station's environmental control systems that process urine into drinking water and use solar panels for endless energy. In fact, submariners endure isolation, akin to astronauts' confined spaces, recycled air, and psychological stresses that NASA studies for Mars missions. A 2020 ESA report highlighted how submarine crews' coping strategies inform space habitat designs, emphasizing modular living quarters and mental health protocols. On X, enthusiasts debate this endlessly, with one viral thread noting that radio waves penetrate space easily but struggle through water, making subs ideal analogs for deep space communication challenges. Credible sources back this. The US Navy's Subsea project, launched in late 2024, uses submarines to simulate spacecraft operations in the ocean's darkness, mimicking space's emptiness for training. Data from this initiative shows subs maintaining operational integrity in low light, high isolation scenarios, directly applicable to lunar or Martian outposts. Laser tech for ranging bouncing beams off Apollo reflectors on the moon mirrors sonar in subs. both analyzing vast datasets to navigate unseen worlds. But here's the rub. While subs excel at withstanding external pressure up to 100 atmospheres, spaceships handle internal pressure of just 1. A subreddit discussion with over 10,000 upvotes calculated that a sub's hull, made of HY80 steel, could theoretically hold in vacuum, but would expand slightly, risking leaks without reinforcements. Cooling is another hurdle. Nuclear reactors in subs used seawater pumps, but in space, radiative cooling panels, like those on the ISS, would be needed. Military declassified reports from 2023 revealed tests where sub-like pressure vessels were vacuum tested, surviving but highlighting vibration issues from launch. Adaptive optics and AI simulations now modeled these, crunching terabytes of data to predict failures. While some experts dismiss direct conversion due to mass, a sub weighs thousands of tons versus a spaceship S, mere hundreds. Hybrid concepts emerge, like Sob's Blacking-class sub-designs inspiring modular spacecraft hulls. This current synergy isn't fantasy, it's driving innovations, from fusion-powered propulsion trends aiming for gigawatt outputs by 2030, to portable life support backpacks tested in Antarctic analogs, preempting doubt. Divergence in design philosophies for stealth, spaceships for speed seems insurmountable. But cross-pollination in labs like the National Ignition Facility, pulsing 500 terawatts for fusion, suggests shared futures. Our night skies and ocean depths are converging, symbolizing humanity's dual quest inward and outward. Building on that foundation, let's explore the future implications, where rapid tech leaps could make submarine spaceship hybrids not just viable, but revolutionary. By mid-century, materials like graphene, composites 100 times stronger than steel, yet lighter, could retrofit subhulls for vacuum tolerance, addressing weight woes that currently doom launchers. Imagine a world where nuclear propulsion evolves. Subs already harness fission for decades-long voyages. Pair that with emerging small modular reactors, outputting 300 megawatts, and you get spaceships cruising to Mars without refueling. Trends on XBuzz with this hobbyists calculating that adaptive ion thrusters, tested in 2024 by NASA, could replace sub-propellers, providing efficient vacuum thrust at 50 kilometers per second exhaust velocity. Data from the Artemis program shows radiation shielding advancing via water-filled walls, a sub-staple, blocking 90% of cosmic rays. Future life support, closed-loop systems, recycling 95% of water and air, are scaling up, with biotech like algae bioreactors piloted in sub-simulations producing oxygen and food. Implications ripple outward. Cost savings could democratize space, turning $100 million subhulls into multi-role vessels for asteroid mining or ocean to orbit transfers. Urgency mounts with climate shifts. Rising seas threaten coastal bases, pushing naval tech skyward. While timelines draw skepticism, breakthroughs like SpaceX's Starship reusability, slashing launch costs to $10 per kilogram, suggest feasibility sooner than thought. This isn't hype. Logical extensions of current trajectories, like ESA's submarine-inspired habitats for Europa's icy oceans, blend realms. Speculate bolder. Global collaborations could yield hybrid fleets, deterring space conflicts while exploring. Yet, address counters energy limits. Cap thrusts, but fusion pulses hint at overcoming. This future evokes excitement. Humanity's tools evolving, from sea conquerors to star voyagers, fostering progress amid peril. Finally, let's ignite your imagination with a speculative scenario that's bold, yet grounded. Picture a modified Typhoon-class sub, the world's largest, reborn as the Orion Pioneer. In 2045, after years of retrofits with carbon nanotube reinforcements and plasma thrusters, it launches atop a colossal reusable booster, shedding ocean gear for space sails. The crew, veteran submariners turned astronauts, fills the familiar hum of the nuclear heart, now cooled by deployable radiators glinting like wings. As Earth recedes, microgravity sets in, but anti-atrophy centrifuges spin, mimicking subdives. They glide past the moon, lasers mapping craters as sonar once probed trenches, data streaming back via quantum links. Challenges arise. A solar flare hits, but water-shielded hulls absorb the blast, just as pressure hulls defy depths. Propulsion kicks in. Hybrid engines, fusing sub-reactors with ion drives, propel them toward Mars at 0.01 grams acceleration, a gentle push over months. En route, they simulate black hole dives with onboard AI, analyzing petabytes for breakthroughs. Arrival. The sub descends, aerobraking through thin atmosphere, parachutes deploying like depth charges. On the red surface, it becomes a habitat, drilling for water as it once hunted subs. Crew emerges, planting flags in regolith, evoking all humanity's bridge from abyss to stars. But realism tempers. Beam divergence scatters signals, fixed by optics. Thermodynamics caps heat, managed by smart alloys. This isn't fantasy. Calculations show with 8 petawatts input matching upgraded reactors, the sub could orbit shift moons over eons. Earthside reflected insights revolutionize tech, from climate fixes to alien signals. Wonder surges. Could this unity propel us further, mining asteroids or contacting eatwaits? The dual-edge progress or overreach forces reflection. We've voyaged from oceanic crushers to cosmic dreamers, unveiling how submarines and spaceships dance on innovation's edge, grounded in NASA sims, fusion labs, and naval prowess. This what-if illuminates our potential to conquer extremes wisely. What sparked your curiosity most? Clit subs truly harp. Share your wildest ideas below as might fuel our next deep dive. Smash subscribe for more universe-shaking explorations, ring the bell for alerts, and spread this to your crew. Keep dreaming big, the frontiers await. Until next time, explore boldly.